Hello, everyone. David Phillips from Clouding here. I'd like to take a moment to look at the key infrastructure component of direct-to-consumer streaming as this is the focus of this summit, and that's storage. At Clouding, we've developed an on-prem object storage platform called Hyperstore that provides a highly scalable global namespace and utilizes a native implementation of Amazon's S3 API. Scalability of our storage combined with this S3 compatibility has drawn many media companies to our solution as they look to solve the challenging problem of managing growth while also containing costs. The deployment of Hyperstore for the Nikko video service in Japan provides a good example use case and forms the basis of my talk today. Along the way, I aim to go bit more detail about what makes object storage uniquely suited for supporting online video platforms. Before we turn our attention to Nikko, I'd like to just level set since we're talking about types of data storage. While this slide may seem elementary to some in the audience, I think it's relevant to touch on these categories because some of the traditional assumptions about each of these types of storage has started to shift and change in recent years. Traditionally, scanning from left to right, you might assign, different storage types, distinct qualifiers in a range, such as fastest to slowest, or most expensive to least expensive. And we can also assign the qualifier of most scalable with object storage taking that title. But this kind of categorization still holds true for the most part today, where block storage provides the lowest latency and is really best utilized for things like structured data like databases and data storage for virtualization. Object storage was really developed as a way to solve the problem of how to scale to very large sizes with also, within economic limits by using commodity components strung together with a kind of software layer architecture. It would be very difficult for block and file storages to kind of achieve the scale of many object storage deployments today. When you think of something like YouTube, a web scale platform like YouTube, hosting over 5 billion user videos and serving out that many views on a daily basis, it's not something that would be technically or economically feasible with block or file storage technologies. If we take a closer look at object storage itself, from a high level, most all object storage solutions utilize a design based on individual storage nodes that connect together to form a cluster. Adding nodes together, we can create a storage domain. So this utilizes a clustered database in software that stores all of the both the metadata about the objects in the storage domain, as well as all of the system metadata in the storage cluster itself. As files are written to the storage cluster, the object storage software fragments each file and distributes the fragments across the nodes based on the data protection level set by the storage policy. All of the metadata about that file, both the technical characteristics, the size of the file type, custom tags and labels, as well as the location of all the fragments, are stored in a cluster database that's also distributed across the nodes in the cluster. Key aspects of the storage design are that the storage software has a level of separation from the underlying hardware. And in turn, the resulting storage interface, the unique endpoint URL, has a layer of abstraction from the storage subsystem. When you put all this behind a network load balancer, it becomes very straightforward to add capacity to the cluster, which in turn adds performance and also fault tolerance. A read-write request can simply be routed to around any node failures to the next available instance of the data, the next available online node. This kind of architecture allows an object storage design to scale to extremely large sizes, as we've seen with all of the web scale platforms like Facebook, Instagram, YouTube, etc. So with that background, looking at customer use case, we have a customer in Japan, Nikko is the site. The company, their parent company, Dwango, is a Tokyo-based media company, hosts a number of different services from games to VR, events, education, mobile apps, mobile games. Their Nikko video service is it's a social network video service that provides video sharing and live streaming with comment posting. In any given month, Nikko often draws enough user traffic to rank it as the 10th most visited website in Japan. Varies from month to month, but it's typically in the top 10 of web traffic in the Japanese market. I don't speak Japanese, but in kind of touring around the site, it has a certain YouTube video sharing feel to it. This is an example of a uploaded video of a demonstration by a sushi chef, of how to properly prepare a fish, for sushi in a sushi restaurant. So this is kind of familiar from users of the YouTube platform. Obviously, this is very targeted to the Japanese market and kind of a lot of the niche concerns with Japanese audience around Japanese culture, be it anime, food, history. So when the service launched in 2006, it was difficult for them to predict the amount of storage capacity and bandwidth allocation that they would need. The storage administrators at Dwango found that their traditional file and block storage, with its typically high cost per terabyte and limited scalability, was not optimal from both a financial and an operational standpoint. They also saw that as the popularity of the service took off, they saw the data footprint grow and the demand for using that data increase. The company was also seeing greater storage costs and inefficiencies, along with this growth. So it became an issue where, they became the victim of their own success as they now had to try to manage the explosive growth from their user base. In the words of one of the storage administrators at Dwango, we need an integrated, scalable, and easy to manage solution to keep costs low and to support our rapidly growing storage footprint. Hyperstore was very attractive because it fully native S3 API means that there's no protocol conversion layer, and it making it easy to configure and to integrate new S3-based applications in the future. So this Dwango storage team, they determined that object storage would be the best way of addressing their needs, and after exploring different options, chose Cloudian. And this S3 API compatibility was a key component of their decision-making process. This is something that we hear quite often talking to customers in the field, in that when they're first starting out, they don't know how their deployment designs may change in the future, but they know that they want to have options and not be locked into a single deployment model. And this is what is so key about the S3 API. As the de facto industry standard for object storage interfaces, the S3 protocol allows platform architects the ability to develop their storage routines once and deploy it anywhere, from private cloud infrastructures to public cloud, and even hybrid designs, in between, kind of spanning the private and public cloud domains. While Hyperstore's native S3 API implementation was central to Dwango's decision-making process, equally important was the fact that Hyperstore is a software-defined storage platform. Decoupling the storage software from the underlying hardware provides many benefits, but the Dwango team saw an opportunity to integrate the Cloudian software stack with SSDs in an all-flash configuration that could serve as serve primary storage functions that would typically be deployed on block and file storage that, where there was a performance requirement. Extensive testing confirmed that Hyperstore could maximize the performance of the SSDs, allowing the storage team to deploy it as primary storage for Nikko illustration images, live broadcast thumbnails, and news photos, and as the foundation for an internal storage as a service offering. This SaaS offering has enabled Dwango application developers to reduce their dependence on public cloud services and avoid the inconsistent performance that those services often entail. As a result, the company has accelerated application development time. Again, in the words of the Dwango storage administration team, since adopting clouding, the operational load and cost of storage has been greatly reduced, as we're able to manage all of our storage from a single point. Looking forward, we expect our data to at least double over the next 1 to 2 years, with content demands also increasing. With Hyperstore's scalability, manageability, and flexibility, we're confident we'll be able to meet the resulting challenges and capitalize on the opportunities all this entails. So if we look back at our object storage design diagram, we can see, the majority of our customers are looking for the lowest cost per terabyte possible, and often simultaneously the greatest rack density possible, as rack space in a data center is also a precious commodity. This is often achieved with up to 16 terabyte spinning disk drives and disk enclosures holding up to 96 drives in a single 4RU chassis. The use case example of Nikko in Japan speaks to the flexibility of software-defined storage on commodity hardware, where a customer can adapt the storage platform to meet their specific performance or capacity needs, while also containing their storage expenditures. Being able to bring in a storage solution under the price of traditional block and file storage. I think it's important also to, in talking about object storage architecture design, to when we talk about scalability, it's important to note that object storage designs inherently support scaling across geographic zones, across multiple data centers and multiple regions. This provides a key aspect of high availability at larger scales, which is often essential for revenue-based streaming operations, where any downtime or outages, can impact revenue. So, rounding out my presentation today, I just want to touch on some key takeaways. I think, what I'm demonstrating today is the flexibility of object storage, and that when you have a software-defined platform, you have, the options of multiple design profiles. It could be optimized for performance or capacity. The thing that really ties it all together is a common S3 API, which allows you to migrate workflows between the private clouds, infrastructure, on-prem, and then for certain key workflows, you could migrate those up to the public cloud infrastructures without having to refactor all of your storage interface API calls. Cost effectiveness is really, what draws many people to object storage in the first place. Being able to really take advantage of commodity x86 hardware, a lot of open source software libraries can be employed to reduce the total cost of ownership for on-prem private cloud storage based on object storage. Many customers are also looking for a way to get out of vendor lock-in, which means that they don't, as hardware ages out and goes out of warranty, they can take advantage of different vendor solutions in the future to really get the best price performance benefits at that time, at the time of their hardware refresh. And when you talk about scalability and talk about direct-to-consumer, you need to be able to scale quickly and easily and scale out designs that support billions of files and exabyte level capacity speaks to the kind of web scale capabilities of object storage designs today. Also, having an API-based storage that supports both the local area network resources as well as can be stretched across a geo-distributed WAN network. So thank you for taking the time today, and I will pass it back to the IABM team.